So we are going to continue on in our lessons about applications of functions. Particularly, we're going to talk about modeling using linear equations. Remember, a linear equation comes in the form of y equals mx plus b. So some tips for these types of problems is determine the starting value or starting point or some type of fixed or initial cost. This is b. Determine the rate of change. This is m. And our equation will look something like y equals mx plus b, or f of x equals mx plus b, but with the variables that were given. Okay, and a linear model means that the shape of the function is a line. So for instance, if you have something like this is not a linear model. It's something curvy or wavy, but it's not a line. Okay. So example 1, suppose all items at a clothing store cost $5.50. This is $5.50 per item, cost per item. Okay, so fill in the table with the correct response for the cost, f of x, of purchasing x items. So if you don't purchase any items, you're going to spend $0. Okay, there's no fee for getting in this store or no cover charge as outlined in the problem. If you buy one item, we have $550, and we're only buying one item, not $550, $5.50 times 1 is 5.50. If we buy two items, we have 5.50 times 2, which is $11. And if we buy three items, we have 5.50 times 3, which is $16.50. Okay, and I set it up in this way because you can start to see an equation forming. If I replace the number of items with x, I have a formula to find out the cost of purchasing x items. Okay, we take the cost per item times number of item, and that would give us how much we would spend. So for part B, this should say write the linear function that gives the rule for finding the cost. So $5.50 per item, that's language of slope. And in a linear function, slope is the same between the increment that we're using. So for instance, between buying one item and two items, the cost change is going to be $5.50. Two items to three items, $5.50, and so on and so forth. Okay, so that is going to be our slope. We don't have a y-intercept in this case. Again, there's no fee for getting in the store. There's no fixed cost to shopping there. Like if you were to talk about shopping at Costco, for instance, you would have a membership and let's say it's, I don't know, $5 per box of ice cream you buy, and you want to know, write an equation for that. You would have to factor in the cost of the store membership into that, but we don't have anything like that here. So this is f of x is equal to 5.50x. Example 2, fill in the blanks using the graph. So I'm going to zoom in on the graph. Okay, so our independent variable is time, and it's measured in hours. Our dependent variable is distance from the beach. So it looks like this person is driving from their house or from some starting point to the beach. So at 1 hour, they are 250 miles from the beach. And as they're driving at 6 hours, they're 0 miles from the beach, which means that they have arrived there. Okay. So according to the graph, the distance from the beach, it's either increasing or decreasing. In this case, since our line is going down, our distance is decreasing by, we can just say we start at 250, we end at 0, by 250 miles every 6 hours. So calculate the slope and represent it as a rate of change. So my slope here is going to be negative. So remember, when it's decreasing, we've got a negative slope. Negative 250 over 6, which is negative 125 over 3. This is miles per hour. Okay, our dependent variable over our independent variable. Okay, so our slope would actually be the speed of the car here as absolute value. Okay, and in terms of this model is valid if the speed is constant, which going from Las Vegas to any beach, you're probably going to hit traffic. So this may not be realistic, but that's what's being described here. Okay. Example 3, suppose your house was valued at $270,000 when you bought it in 2019 and is valued at $371,000 in 2021. Based on these two data points, find a linear function that describes how the value of the house varies with years. Okay, so what we need to do is we're ultimately looking for some type of equation in the form of y equals mx plus b. We have 2 points that we could treat as two ordered pairs in order to find this equation. One thing, if you look ahead, so in MyLab, it might have you fill in a sentence. The equation used to model this situation is, and it gives you a blank, where V is the value of the house in years, so V will play the role of Y, and T is the time in years since 2019. So 2019 is counting as like year 0, so I recommend using that instead of 2019 when you're working with this equation. Okay, so our 2 points, we have 0 and 270,000, and we have 2021, which is 2 years later, and 371,000. Okay, so in order to write this equation, based on what it told us, we are looking for an equation in the form V is equal to MT plus B. So V is the value and T is the time in years since 2019. So we first need to find our slope. So this is similar to finding the equation of the line using 2 points, only in this case we have an application. Okay, so M is equal to y2 minus y1 over x2 minus x1. Okay, and if you plug this in, we get 101,000 over 2. So we divide that by 2 and we get 50,500. So this is our slope. So if we start to build the equation, we have V is equal to 50,500 T plus B. And now we need to determine B. You can plug in a point, and I would probably plug in 0, 270,000. But remember, for our y-intercept, the coordinates are 0, b. So if we have the coordinate 0, 270,000, 270,000 is our b value. Okay, so our final equation, if you plug in 0, 270, you'll get the same thing. Okay, and I can actually show you what that looks like. So notice the 550,000 times 0 goes to 0, and b is equal to 270,000. So our equation, our value is 50,500 T plus 270,000. Okay, so that's what would go in this line here, and it's important to use the variables that are asked for in the problem. Next, use this function to predict the value of the house in 5 years and in 20 years. So let me write the function at the top. Okay, so in 5 years, we would say that T is equal to 5. So we would find the value by plugging 5 in for T in the equation. Okay, and we would get 522,500. And then we would do the same. So for T equals 20, we would find V is equal to 50,500 times 20 plus 270,000. And if we plug that in, it would be 1,280,000. Okay, so next, discuss the validity and any limitations of this model. So first of all, values of homes do not usually go in a straight line over time. This is valid for a very short period of time. And maybe it works in 5 years with this crazy market we're experiencing in 2021, but it's unlikely that it will continue along that long term. Okay, it's just not stable. So anytime we're dealing with modeling, there's always limitations based on the real world factors that are around us. Okay, thank you for watching. If you have any questions, feel free to reach out to me.